Welcome to a question practice session for NEET 2025. Today we will be covering the topic GOC, in which we'll see the subtopics hybridization and nomenclature. The questions that we have selected today are few from the PYQs and few questions are similar to the PYQs. So hope these questions are helpful for your NEET preparation. The first question is, the pair of electrons in the given carbonyl is given to you, is present in which orbital? So the carbonyl is given. How this carbonyl was formed? CH3, say triple bond, if a hydrogen is attached here. Due to the electronegativity present in this carbon, the hydrogen loses its electron density and lives in the form of H+. So how this bond was formed? Carbon had a hybridized orbital. Okay, this side we don't need to see anything. So hybridized orbital with which hydrogen's s orbital was overlapping. So which hybridized orbital is this? This is sp hybridized orbital of the carbon. So obviously whenever the electron density is coming from the hydrogen, it is coming to the sp hybridized orbital of the carbon. So the answer for this is C, sp hybridized orbital. Second one, the number of sigma and pi bonds present in pent 2in4-ine. First, let's make the structure for better observation. Pent means 5 carbon. So 1, 2, 3, 4 and 5. At the second place we have ene, means double bond. At the fourth place we have ine, means triple bond. Now what we have? Remaining satisfaction of the valency will be with hydrogen. This carbon already 3 valencies satisfied, so 1 hydrogen. Here also 1 hydrogen. All 4 valencies satisfied for the next one. For the last one, only 1 hydrogen required. So let's calculate the number of sigma bonds first. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 sigmas we are getting. So only one option gives 10 sigma. So option should be B for second. Pi also you can calculate. 1 here and 2 here, so 3. So your option will be B, 10 sigma bonds and 3 pi bonds for pent 2in4-ine. Next question. Which of the following molecule represents the order of hybridization sp2, sp2, sp, sp from left to right atoms? So we have to see from left to right. This is the first thing given. And then sp2, sp2, sp, sp is the type of hybridization that we have to observe. Generally, if we see carbon, when it is bonded with 4 single bonds, that particular carbon is sp3 hybridized. If a carbon is bonded to a double bond, that particular carbon is sp2 hybridized. And if it is having a triple bond, that particular carbon is sp hybridized. So when they are talking about sp2, sp2, sp, sp means we need to see double bond and triple bond. So first one, if I see CH triple bond should be what? sp hybridized. So first one should not be the option. Second one, this is a double bond present. So obviously this is sp2. The next one also is sp2. Third one, triple bond, so sp, sp. The option will be B. Double bond is there. So this is sp2, sp2. Triple bond is there. Remaining 2 is sp, sp. Done. Next, fourth one. The state of hybridization of C2, C3, C5, C6 of the hydrocarbon. A hydrocarbon is given to you. So which one is C2? This is C2. Which one is C3? Okay, 3 is not mentioned here. So this should be 3. So this is the C3. Then C5, this is the C5 and this is the C6. Now what is the state of hybridization? If I see C2, triple bond is present. So whenever it is triple bond, sp hybridized. Third one, all the bonds are single bond. So sp3 hybridized. Same question that we have seen in the last question. Same concept has to be applied. C5, double bond is present, so sp2. Sixth one, all a single bond, sp3. So how it is coming? sp, then sp3, then sp2, then sp3 according to this particular sequence. So which option satisfies this? Is option D. So for fourth question, the option is D. Let's move to the next question. The total number of pi bond electrons in the following structure. So pi bond electrons we need to calculate. Let's see how many pi bonds are present. 1, 2, 3, 4. Total 4 pi bonds are present. Each pi bond contains how many electrons? Any bond is made with 2 electrons. Few exceptions are there though, banana bond and all. But normally bonds are made with 2 electrons. So 4 pi bonds, 2 electrons. How many pi bond electrons should be present? 8. So your option for fifth one is D. 8 pi bond electrons should be present. Let's move to the next question. The enolic form of ethyl acetoacetate as shown below. Before going to this, what is enolic form? You may heard about this tautomerism, in which we have keto-enol tautomerism. Keto-enol tautomerism. Now in keto-enol tautomerism, there is a necessary condition that if there is a ketonic group and around the ketonic group we have a alpha carbon which has hydrogen, that is alpha hydrogen is present. So here alpha hydrogen is present. Now this alpha hydrogen can undergo tautomerism. How? This bond, oxygen will take this electron density towards itself. So the carbon will get an electron deficiency here. To satisfy this electron density, this carbon will pull the electron density of the nearby hydrogen towards itself. In doing so, what it is actually making? So C, this oxygen pulls its electron density, negative charge will come. CH3, the electron density is pulled, so C, and H I am getting, where H positive goes out. Now what happens to this H positive? This electron density will pull this H positive towards itself. So finally what I am getting here? COH double bond CH2, and this is CH3. So this form is the keto form. Why? Ketonic group was there, and this form is the enolic form. Alcohol is present. This type of tautomerism is keto-enol tautomerism. Reverse can also happen like this. Okay, so this is the keto-enol tautomerism. Now we are talking about enolic form in the question. So enolic form is this form because this is the keto form. Why keto form? This ketonic group is there. Why this is enolic form? This group, from here the hydrogen came. Done. Now in this enolic form, you have to see how many sigma bonds and how many pi bonds are present. For that, if I elaborate the molecule. So if I elaborate the molecule, how does it looks like? I have CH3 there. C, H, H, H. One carbon attached to this is OH. Then I have a double bond, CH. Then I have a single bond, carbon attached to one oxygen. This is a double bonded oxygen. To this I have C2H5. So C2 and H5. This is 3, this is 4 and 5. This is the complete structure of the enolic form. Means this molecule I am talking about, open structure. Now how many sigma bonds? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17 and 18. So 18 I am having, 18 sigma. Only in one case it is given. Pi also you can check, it is 2. So answer for the sixth one is C, 18 sigma bonds and 2 pi bonds. Keto-enol tautomerism, I hope just in short I have explained, you have understood. So from the alpha carbon, alpha hydrogen gets shifted. So OH form, this is the enolic form, and this wherever keto group is present, this is the keto form. This phenomena we call it as keto-enol tautomerism. Answer is C. Let's move to the next one. 7th. The IUPAC name of this particular molecule. Now in this I have two groups. One is the ketone group, one is the amine group. Wherever two groups are there, we go with priority. We have ketone, we have amine. In the priority series, ketone gets more priority than amine. So whichever gets more priority is written in the form of suffix. So ketone, when written in the form of suffix, we write it as -one. And amine is written in the form of prefix because of the less priority. So we write it as amino. In the form of prefix, we write it as amino. So because of the priority, the numbering will be in this way: 1, 2, 3 and 4. So at the fourth carbon, we have the amino group. 3 amino, 1 amino, 4 amino will be the correct one. So 4 amino, and at the second position we have the -one. Your option will be C for the IUPAC nomenclature. Okay, we have the complete priority series where the acid comes first, carboxylic acid, sulfonic acid. In that way we have priority series. So based on the priority series, we need to somehow remember the priority series. Based on that, we'll answer this kind of IUPAC questions. Next IUPAC question. So this is a molecule given to you. We have to find the IUPAC name. Complete symmetrical molecule. So no problem, numbering can be started from any direction. Let's start from here: 1, 2, 3 and 4. Symmetrical molecule, so no problem. So at the first position and fourth position, I have chloro group. And at the third position and second position, I have bromo. When I have two substituents, I'll follow alphabetical order. So according to this, bromo will come first, then chloro. So bromo is present in which position? Second and third. So 2, 3 dibromo. But here it is 1, 3. Wrong. Chloro is not present at the third position. Right? 2, 3 dibromo, 1. This is the option C. Other options are numbered wrong. Okay. Next IUPAC name. There is a functional group present here. This is the functional group. What group is this? This is carboxylic acid. So obviously my numbering will start from the carbon with functional group 1. This is second one, third, fourth, fifth, sixth and 7th. Either direction I can put 7th. Again it is same. So at the second carbon I have a substituent. At the 6th carbon I have a substituent. Fine. So according to this, what should be the name? Hept will be the thing because 7 carbons are there. So second and 6th position, 2,6 dimethyl hept, 2,5 diene. Okay. So here what we see, substituents are present here, correctly mentioned. Hept 2,5 diene. At the second position and 5th position we have a double bond and oic acid. So the answer for 9th will be A. Okay, 2,6 we have substituent, 2,5 we have the bonds, multiple bonds. 10th one. In 10th, what is the functional groups present? This is aldehyde, this is ketone. Out of the aldehyde and ketone, out of aldehyde and ketone, aldehyde gets more priority. So if aldehyde is getting more priority, it will be written in the form of suffix. Aldehyde in the form of suffix is written in the form of al. Ketone will be written in the form of prefix. Ketone in the prefix is written in the form either keto or oxo. Anyone. Let's see. Because ketone is less in the priority series than aldehyde, so we'll either use keto or oxo. So we'll start the numbering from the highest priority 1, 2, 3, 4, 5 and 6. Hex will be the term. At the third place we have keto. At the second position we have a methyl group. At the fourth position we have a double bond. Let's see. 5 no, this is wrong. On they have given priority, wrong. Next one, 5 methyl. At the fifth position we don't have any methyl group, wrong. Next one, 3 keto. Okay, 3 keto we have a keto group at the third one. 2 methyl at the second position we have a methyl group. Hex, 5 in. They have written 5 in at the fifth position double bond. Actually we'll see the list number, it is at the fourth place, not at the fifth place, right? So this is also wrong. So we'll put the least number, that is fourth place will be in al. So third one, sorry, the C option is wrong. D option is the correct for 10th. Next, 11th question. IUPAC name. How many groups do we have here in this case? We have a nitro group. We have a chloro group attached to benzene. We have a methyl group attached to benzene. I have two ways of numbering this. One is, if I number in this way, this is the first carbon, second carbon, third carbon, fourth, fifth and sixth. Or I number starting from here. This is the 1, this is 2, this is 3, this is 4, this is 5 and this is 6. So you can see like that, blue one or the red one, right? If I see the blue one, why do I have the substituents? I have substituent at the first position, at the third position and at the fourth position. What is the sum total? 8. If I go with the red one, where do I have substituent? At the fourth position, at the second position, at the fourth position. What do I get? 7. Which one is least? 7. So least number we go. According to this, least number we will go. Least number is 7. So I'll go with the red one, removing the blue part. So with the blue way of numbering will not go. Fine. Now according to this number, let's see with the option. First one, 5 chloro. Do I have any chloro in the fifth position? No. 2 chloro. Okay, 2 chloro it is present. Fine. 1 methyl. Fine. 4 nitro. Okay, benzene. So finally what I'm getting? That my option B seems to be correct for 11th one. Okay, at the second position chloro, first position methyl, fourth position nitro. So least number, two ways we have to number, the least number we will follow here. Next one, IUPAC name of this particular structure. From here we can see this is the main chain. Okay, other are substituents. But one problem we have here, cis trans form we need to find out. Okay, if I see around this particular group, both the groups are different. How do I find cis trans? For this kind of cases, we go with the mass factor or weight. Fine. With this particular carbon, with this carbon, the attachment is of another carbon and attachment is of iodine. Out of carbon and iodine, which one has more mass? Iodine gets the more mass. Obviously, iodine will have the more mass because iodine has the more mass. So I'll number it as 1 and number the other side as 2. Similar way, the direct attachment with this particular carbon is of again carbon and chlorine. Out of carbon and chlorine, chlorine has more mass. So I'll number chlorine as 1 and CH3 as 2. If you see this case, what is seen that the chlorine and the iodine, that is, the more number part is on the opposite direction. Opposite direction means it stands for trans. Okay, both the 1 that is, this is the double bond, this side iodine, this side chlorine, this side carbon, this side another carbon, sorry, not chlorine, it's carbon. Okay, this is not chlorine, this is carbon. So this gets more number, this gets more number, so both the 1 are in opposite direction. This is trans form. So all the cis we can cancel it out, cis cancels out. Done this much. So we know the answer should be in the trans form. Now let's see the other thing. If I see the number starts how? 1, 2, 3, 4, 5. So at the second place I have chloro, at the third place I have iodo. At the second place I have what? Chloro. At the third place I have iodo. We'll go with alphabetical order. So chloro, 2 chloro it should be. So trans 2 chloro, 3 iodo, 2 pentene. For 12, B will be the answer. Not 3 iodo, 4 chloro. Then least number will be the answer. Next one, IUPAC name. Okay, normally if I see this particular structure, we call it as benzaldehyde, right? This is benzaldehyde. But in this particular case, we have 2 aldehyde group attachment. So in this cases, we use carbaldehyde, not directly benzaldehyde. This is benzaldehyde. Okay, this is benzaldehyde. But whenever 2 groups are attached, that time we'll use 2 or 3 same kind of groups, aldehyde groups, we use carbaldehyde. So first and second position attachment is there. So benzene 1, 2, dicarbaldehyde will be the answer. This is an NCERT question. It is there in NCERT. Okay, fine. Next, the correct structure of 3-ethyl 2-hydroxy 4-methyl hex 3-in 5-ine oic acid. So this is a big name. Let's check with the options directly. At the third place, I have ethyl group. I have a functional group here. So obviously this is the first carbon, second carbon, third carbon. At third carbon, do you see any ethyl group here? No. So obviously this is not the answer. Again, next option. First carbon, second carbon, third carbon. Do you see any ethyl group present here in this case? Yes, we see ethyl group. Okay, next. 2-hydroxy. Do we see any hydroxy group present here at the second position? Yes, we see. Next, at the fourth, we need to see methyl group is there or not. So if this is 3, this should be 4. Do we see any methyl group at the fourth? Yes, we see. Done. Next, this is 5 and this is 6. So hex, obviously 6 hex. At the third position, we have in. Yes, double bond is present at the third position. 5 position, we have a triple bond, oic acid because of the functional group present. So B is the correct answer for 14. Okay, if the name is big, no need to worry. What we will do, we'll keep on matching with the option which is given to us. Whichever option matches, that will be the answer. IUPAC name for this particular structure, 15. Okay, now see here, in all the options says it is octane. So let's find a chain which is octane. If I start numbering from here, 1, 2, 3, 4, 5, 6, 7. Wrong way of numbering. Hept it is coming, right? If I start from here, 1, 2, 3, 4, 5, 6, 7, 8. It can come. So my numbering is wrong in this way. Whereas one option I am getting how? If I start from here, in this way. So if I do in this way, how much it is coming? Or how do I number? 1, 2, 3, 4, 5, 6, 7 and 8. It is coming like that. So at the third position, I have 2 ethyl group. At the fourth position, I have a methyl group. And at the fifth position, I have a isopropyl group. Fine. So if these are the things I am having, and if I follow alphabetical order, that is E, I and M, I'll get my answer. So first option tells us 3,3-diethyl, okay. Fourth place methyl, fine. Then fifth place methyl ethyl. We don't write it in the form of methyl ethyl. Next option 3,3-diethyl, correct. 5 isopropyl, correct. 4 methyl octane. So for option question 15, B will be the answer. Okay. Question is big, that is the structure is big, just we are matching with the options. Easy. IUPAC name of the structure. How the structure was formed? If I take a aniline, I remove these 2 hydrogens. Instead of one hydrogen, I attach a ethyl group, and another hydrogen, instead of that, I attach a methyl group. So I'll get this particular structure. Fine. So mainly the group is what? This particular group is the aniline group. N is attached to ethyl group and N is attached to methyl group. N we will use why? The attachment of this methyl group and ethyl group is directly with N, not with the benzene ring. If with carbon, we number it. If it is attached to carbon, we number it 1, 2, 3. For carbons, we put numbers. Whenever it is attached to nitrogen, we write the name as N, that particular thing that is attached to nitrogen. Okay, so N-ethyl, alphabetical order is followed, then N-methyl, aniline. This will be the answer. Next question, the IUPAC name of this particular structure. What do we find here? We have 2 different functional groups. One is this particular group, another is this group. So what are this group? So this is nothing but carboxylic acid. To this attached is aldehyde. So out of aldehyde and carboxylic acid gets more priority than aldehyde. So this will be taken in the form of suffix and written as oic acid. This is taken in the form of prefix and is written in the form of oxo. Right? So one hydroxy group is not present anywhere. Second one is oxoethanoic acid. So 2 carbons, 1, 2, obviously ethanoic acid. Oxo stands for the aldehydic group. B will be the option for 17th. So whenever aldehydic group is there or ketonic group is there, ketone also if it is there, then also if prefix it is used, we use as oxo. Sometimes we also use as keto. Like this one we have seen in a previous question. Today only we have discussed. Fine. The last question for today's session. The IUPAC name for this particular structure. So if I number it 1, 2, 3, which direction I'll go? Either direction it is not symmetrical. I'll prefer to go in right hand side because I'll get more number of substituents with this. So this is the first carbon, second carbon. Why did I choose this first carbon? Because of the double bond. Third carbon. So at third place I am getting a substituent. Fourth carbon also I am getting a substituent. This is fifth and sixth. At the third place, which substituent I am getting? Propyl. And at the fourth place I am getting ethyl. I'll follow alphabetical order. So ethyl will come first. So let's see. 4 ethyl, correct. 3 propyl, correct. 6 carbon, so hex. At the first position, ene is present. First option seems to be correct for question number 18. Okay. So that's all for today's discussion. Today we have discussed on the topic hybridization of the organic molecules, that is sp, sp2 and sp3, which carbon they are forming, number of sigma bonds and number of pi bonds that are present, that we have discussed. Also we have discussed the IUPAC nomenclature. So these are few of the topics from the chapter GOC which we have discussed the questions. Okay, so remaining things we'll see in the next session. If suppose any one of you have any doubt on any topic, any other topics also, if you have doubt, you want to clarify those doubts personally with us, we have a team of teacher. You can contact this email ID. We will refer to you, will contact you, and then you can solve your doubts with us. Okay, thank you for visiting our session. Thank you.